Volumes of pyramids and cones. Though I don't have a way to prove this without using calculus, the volume of a pyramid or a cone is 1/3 the volume of a prism or cylinder with the same height and base. So that means that if we took the formula that we usually have for prisms or cylinders, that volume is equal to capital B times H, where capital B is the base area, what we're going to do is add in an extra factor, which will be 1/3. So that's what we're using. And of course, capital B is going to be unique depending on what figure that we're looking at. Okay, if it's a pyramid, capital B could be a square, it could be a rectangle, it could be a hexagon, it could be any type of polygon. If it's a cone, then capital B is going to be pi r squared for a circle. Example 1, the entrance of the Louvre Museum in Paris is a glass pyramid with an edge length of 354 meters and a height of 21.6 meters. Okay, so it might be hard to see in the picture here, but you do have a square pyramid. This would be a base. Well, that would be the base, right? You got a square base here, which will be 354 by 354. The true height of this, the true height measured within that figure is going to be 21.6 meters. Okay, and the question is just what's the volume? Okay, so we'll start with volume is equal to 1/3 capital B times H. But capital B is going to be a square here. Okay, so for a square, actually I didn't space that out enough, did I? Okay, for a square, the two dimensions are the same, 354. The height is that number. Okay, so let's think about what happens when we do multiply these together. These two give you the area of the base. It gives you the area of this square base that we have here. If we were just to multiply by the height, it would treat it like it was a big box, a rectangular prism. But by multiplying by the 1/3, you'll actually get the volume of the pyramid. All right, let's see what that turns out to be. We got 1 divided by 3 multiplied by 354, which we can just square. Multiply that by 21.6. And we get 902,275.2. And that would be meters cubed. For example 2, let's go ahead and take a look at a cone. In this case, it is an oblique cone. That means that the center point is not dead center with respect to the base that we have underneath it. However, to calculate the volume of this figure, you're still going to be using the volume is equal to 1/3 capital B times H. Of course, a cone is not a polyhedron, which means that it is going to have a unique formula, just like the cylinder has. Okay, so the volume is going to be equal to 1/3. The base area is the circle, which is pi r squared, and your height is the true height of the cone. Okay, so for this, we've got 1/3 pi. The radius is going to be half of the 30, so you got 15 squared, multiplied by the height, which is 25. And again, like the pyramid, if we were to look at the calculations here, the pi r squared gives us the area of the base. If you were to multiply that just by the height 25, it would actually give you the volume of a cylinder. But by multiplying by the 1/3, you actually get the volume of a cone, regardless of where that point is actually sitting. Okay, so let's see what that looks like. We got 1 divided by 3 times pi times 15 squared times 25. So we get 5,890.5 feet cubed.
Wait, there was.